Okay. So the reason why we have these is because we now have the ability to transfer files or send email or manage other computers or talk to each other or even do video chat over applications that everybody knows about. And it becomes very common to build up these applications and to know the ports. Now, ports are very important when you're doing networking. Naturally, ports are the way that computers receive traffic. Traffic on the internet looks like this. They're just electrical signals that are either a one where there's electricity present or there's a zero where there's no energy present. The internet is very musical in that there's a common clock or a pulse that's maintained and everything is delivered over a clock. And the clock is what determines the start and end of messages. Messages have a particular length, and when clocks are synchronized across the internet, then we know when messages are starting and ending. So ports are relevant in that they are sending an unending stream of traffic in the form of ones and zeros. And then ultimately, the application is encoding that traffic into a format that one can read. So those ones and zeros ultimately become emails, or the ones and zeros become pictures, or the ones and zeros are made into streaming film, or they're made into voice. But ultimately, the internet is just a series of electrical impulses. Again, defense electronics. So if you're able to send the bits, and the bits can eventually become words, then you have the ability to encrypt words. So here is the arrival of a classical technology, the same way that Turing took the Roman cipher and simply mechanized it on an industrial scale, made it so that you could have hundreds of different ciphers being cracked. And a message might take days to crack under this kind of system. We're also utilizing encryption in the actual messages that we're sending back and forth over the internet. So if you take a port, i.e. you're taking an application and then you apply encryption to the data inside of that port, then technically you should be able to do what the Romans could do, but at the speed of the internet, where you could send a message to somebody, or you could have a text chat with somebody, or you could manage a computer in real time. I do it all the live long day. It's something we're doing right now. It'd be very hard for other people to intercept the meeting that we're having right now unless they had a password, and the password would provide a person with the means of decrypting this message. So in the 90s, we had corporations such as Netscape establishing a secure sockets layer, which was a way to set up a secure handshake with another communicator. So you would set up a communication with another computer, another person, and that in that process, once you had ascertained the identity of the person that you're speaking with, you would exchange an encryption key with that computer, and then the computers would establish a channel of information exchange that would include the key. So this cipher key would be sent to somebody over the SSL. And so the message that I have is when you are using SSL, you can assume that your conversation is encrypted and cannot be decrypted through normal means. Now, of course, there are technologies out there that can decrypt just about anything, but most likely you guys are not having to worry about that. For example, Vache or Alan, Brianna, all of you probably lack the means to crack open the encryption on other people. But believe me, IBM, China, we are constantly utilizing quantum computing in order to decrypt each other's messages. We are using post-silicon technologies in order to decrypt and encrypt. But that's not happening in the consumer domain. The consumer web traffic is very secure when the SSL is being used. So I think people are led to believe that their web traffic is insecure, or it's intercepted, or people are reading your emails when you're at Starbucks, and that's not happening. That's, people are not seeing your credit card when you transact with Amazon. If you have, and this is my message, if you have SSL, and if you see that you are utilizing the HTTPS protocol, here, let's try to, you see how I have the HTTPS in my transaction with Google, you can assume that your traffic is encrypted. And this is why we have e-commerce. And if you can think of Amazon as a kind of imperial dominion, that is precisely because Amazon possesses message integrity. The encryption is what enables Amazon to prevail. So what I'm going to have you guys use is a tool this week called Wireshark. And Wireshark will actually intercept the internet traffic inside of your house. And I'm going to prove to you that the traffic inside of your house is encrypted insofar as they are using SSL. So you can see these images of Wireshark. You're going to run Wireshark and you're going to look at the traffic that is inside of your home. And you'll realize that there's a difference between the internet traffic and the message. So the message is absolutely readable. So if you guys were to go to, the Starbucks on campus and you were to send an email to somebody else, everybody can read the encrypted message. They can read the cipher. So for example, they can read the gobbledygook that you are sending. The unintelligible message is trapped. The zeros and the unlegible message, the cipher, is caught by other people. It's called a promiscuity. It's called a promiscuous setting, where your Wi-Fi interface can actually capture all of the traffic within the local network, within the room or within the library. Your Mac card or your Wi-Fi network card is capturing all of that information, but it's probably not able to actually read a single message except if somebody has given you the encryption key. So the internet as it stands is currently built upon the foundations of encryption, and it's getting more secure as we go further. The internet has become more essential to our daily lives, and our message integrity has become more secure. So I don't want anyone within the sound of my voice to be concerned about whether people can read their traffic when they go to a Starbucks, or I don't want anybody within the sound of my voice to be concerned about whether another person can read the messages that are going back and forth to your phone. Nobody can read those. But SSL has to be present in order for that message integrity, that privacy to be present. Good. So you guys are going to be using Wireshark. Now, I was thinking that I would demonstrate an application, but I think we're going to ignore that. I think we're going to just keep it very simple this week, and we're going to experiment with SSL and Wireshark and looking at traffic. But making applications that operate over a port is something that our students do all the time. So for example, here is an example code of an application that roughly takes this many number of lines in order to make an internet-facing application. And you can see how simplistic this is. I'm using the Node.js library called Express, and I'm configuring a port number. So let's say I wanted to do an SSL a transaction, or let's say I wanted to make a port to run HTTP, that would be fine. Or if I wanted to establish my own port, that would be fine. Most of you are using video games that are utilizing code that works like this in order to establish a unique port to exchange the state of the video game that you're playing. A real-time video game is exchanging a lot of position, the player's position, but they're doing it over a unique port. Yep. Yes. Yeah, it's a very. Do you use a VPN currently? Yes. Yeah. Right. Yeah. I I think yeah, his point is very well taken. What the VPN does is it establishes what's called a proxy server, and you can you guys say the word proxy server? What happens is the Nord VPN, you send all of your traffic to Nord VPN, and then all of your requests for traffic flow through Nord and they go to their destination. So let's say you wanted to go to Netflix, all the Netflix traffic would flow through Nord and then back to you. And so technically, if a government agency wanted to say, hey, Stefan, you're not supposed to watch House of Cards, technically, Stefan Bunn never requested to watch House of Cards. Technically, NordVPN requested to watch House of Cards. And so I've used the proxy before and they work really well. I have not used one for quite some time. And I remember setting up a proxy, and I don't envy anybody having to use a proxy, but it is true that, for example, the Chinese are very accustomed to using VPNs because their country is, they're not supposed to access certain things. The information is very clamped down. It's become more restrictive. China has become a very totalitarian environment. And, what would it take before our nation became very totalitarian? Well, people are debating that right now in Congress. I think I think the need for privacy is motivation to get a VPN. I, I, I'm not saying that you need one, but, I think that right now in Australia, if you protest COVID or you say something online about COVID, the cops will come knocking on your door and potentially arrest you for for communicating your viewpoints online. And so on a society by society basis, there's a different sense of security. And, I see governments all over the world behaving in a very Chinese fashion. You're supposed to have freedom, but, you know, that's an interesting kind of business application. Like, for example, should you create a VPN that is easy and that, the technology's been out there for quite some time, but, I think NordVPN succeeds because, I think people perceive that it's well done and they market themselves well. So moving on. Now, I think where we go is we go from the internet, which is, this distributed network around our country, to right now where the stock exchanges and the entire financial world is really taking place inside of a server room. And that's the way that we have accomplished the last 25 years of finance, is in having computers intermediate all of our traffic. And I think you could understand that the orders, the sensitivity of the content of those orders is such that you must encrypt everything. And encryption must be at the heart of all of these transactions, or we simply could not have, anti-secrecy inside of our financial transactions. Imagine the value of knowing what other people were going to order before they ordered, before the order got processed. It would be kind of a financial secret weapon. It would be equivalent to the Rothschilds, using horseback messengers in order to know the results of Napoleonic wars before anybody else in Britain. The world's great fortunes, modern fortunes, are founded on the organization, the capturing of information, the Rothschilds, and then imperial organizations such as the Rockefellers in the early oil systems. The people who are the most influential in the political and economic spheres right now were simply experts at administering geographic networks, geographic information systems. So what we have right now is a financial system that depends very much on financial secrecy in order to work properly. And let me say this: if you're a user of Robinhood, all of your orders are known to Robinhood before they are orchestrated. So I find Robinhood very beneficial to the investors because young people can invest without fees. It's cheaper. But you must understand the reason why there are no fee investing is because there's a very significant hedge fund called Citadel that owns Robinhood that can see each of your buy and sell orders, and they will actually front run the order. So if they see 1 million Robinhooders planning to sell Apple, well, they know that they can short Apple, and they have a few seconds of notice time, and that's quite enough to make Citadel into a multi-trillion-dollar business. I think that Citadel, I've looked at their investor pages, and Citadel, who owns Robinhood, they earn about $2 trillion a year in fees. So that's kind of the future of finance, is anti-privacy, is front running and looking at the order flow of people who are receiving discounted financial services. And I don't criticize Robinhood. I think it's a good move forward. But understand, I think it's quite a financial innovation. The anti-privacy element. So what I will say now is, probably those of you who are kind of hacker types and are interested, probably you've experienced password crackers. And basically what Turing did with his imitation machine, our students can do with a laptop in, billions of times faster in terms of guessing combinations of characters that fill in for people's passwords. Most computer information systems are not vulnerable to password cracking because if you fail to enter a password correctly after 5 tries, most of them will shut your account down for hours. And so most password crackers do not succeed on more sophisticated networks. But I find that users are vulnerable to, and this is why you need an antivirus, or you need something like a Microsoft Windows Defender. That's a good idea to keep your Windows updated. Also, Macs are very hard for people to get malware and keyloggers. And so it's much better for a person to install a keylogger on your machine than try to crack your password. Keyloggers are something to be concerned about. So I think that's kind of the ultimate, the space of information security is whether your desktop computer has been updated and is impervious to not to password cracking, but to malware and keyloggers. That's the thing that keep me up at night. So that's good. So when we get back next time, I'm going to shut down the video recording, and then I'm going to take a moment to speak with the class.